The next process that we're going to look into is drilling process. So drilling process create a round hole in the work part. So compared to the boring, which can only enlarge an existing hole, drilling you can create the hole from using the drill bit. So cutting tool is called drill or drill bit. So the machine used is drill press. In drilling process, you can create two types of holes. One is through hole and another one is blind hole. So if you want to create the through hole, here is the illustration. So the first one is the through hole. Once the drilling tool bit come out, so it will come out from the other side of the the workpiece. So in here, what you have to know, the parameter that you have to know inside here is the diameter of the drill bit. Okay, so this is the diameter of the drill bit. You have also point angle that you have to know, because in the calculation later you will use this value. And A is the allowance between the tool and also the workpiece. Okay, approach allowance and the thickness of the workpiece. Now for the blind hole is a hole that does not go, the tool bit did not go through the workpiece. Okay, so meaning that the hole is not going, and not like a true hole. Okay, so here the parameter is the same except for the D value. So D is the hole depth. Okay, so the whole depth of the operation. Thing that you have to take note is the drill bit size. So since the hole is depend on the size of the hole depend on the size of the tool bit. So if the size of the hole created also bigger than the size of the tool, so for example drill bit have their own limitation, limit maximum number of the diameter. So this one is just example, you can refer later in the table in the internet. There are limit size of the drill bit. Okay, so since it is depend on the whole size, the tool bit size. So if you want to create a very big hole, what you have to do is maybe first you can start with the drilling of the workpiece, and then you have to finish it with another process, which is boring process. Here is the cutting condition in drilling. So the equation is still the same, n equal to v over pi d for the rotation, and then feed, you still using the same equation, which is fr equal to nf. For machining time, it's a little bit different. Okay, so if it is a through hole, usually for turning it is L, right? But since this one is depending on the how long the tool bit going down. Okay, so then it involve the thickness of the workpiece and also the allowance. Okay, so then you have to add this one and divide by fr. Okay, so for allowance, A equal to 0.5 d tan 90 minus theta over 2. So this is the how you want to calculate the A value. Okay, for blind hole, so this one you have to change the T with the D, which is the depth of the hole. Okay, and then for material removal rate, you can use pi d squared fr over 4. So here are some operation related to the drilling. For example, A is reaming. Reaming is usually used to enlarge the hole to get the close tolerance, or it's also to improve the surface roughness inside the workpiece here, because sometimes after the drilling process there will be a BUE inside here. Okay, so then reaming can be used to clean the surface and make a very good surface for the drilling process. And then tapping is when you want to create the inside thread inside the hole here, so then we use the tapping process. And counter boring is to create a hole for the screw. Let's say you want the shape inside here to be like this, okay, so that when you fit the screw, it goes with the same level of the workpiece. Another process is countersinking. Countersinking also quite same with the counter boring, only that the shape for this one is a little bit different. So after the drilling process, it will look like this. Okay, so you know that there are screw that with this kind of shape, right? Okay, and then center drilling is performed usually before you start the drilling, the real drilling process. You just want to create a small hole so that it's much easier for the drill bit to go inside. Okay, and then we also have spot facing. So after the drilling, you might want to have a very clean area over here, or smooth surface. So then spot facing can also be performed on the drilling machine. So here are some videos related to drilling process. You can look into it, and maybe it can help you to understand more on drilling process. Another problem for the drilling, so if you can try it on your own first, because the way of how to calculate this one is quite the same like the turning example previously, only maybe the equation is a little bit different because this is a turning operation. So give it a try. If you have any problem, you can always contact me so that I will help you. Okay. So the next process is milling process. So milling is a machining operation where work is fed past a rotating tool with multiple cutting edges. So here are some facts about the milling. So axis of tool rotation is perpendicular to the feet. So the tool and also the work material, the movement is perpendicular to each other. And then cutting tool called a milling cutter, and cutting edges called teeth. Okay, so because they have multiple cutting edges, so if let's say they have 5 cutting edges, so we call they have 5 teeth. Okay, so machine tool called is milling machine. It is an interrupted cutting operation, meaning that you can on the machining and then you can off and then you can restart again. So that's what we call as interrupted cutting operation. It is not like just continuously operation, so meaning you can perform it on and off. Okay, so basic milling operation creates a planar surface. Planar space meaning it is a flat surface. Okay, but you can also create other geometries, not only the planar surface. Milling have two forms meaning two arrangement. Okay, so the first one is peripheral milling. If you can see, the tool and also the work material is parallel to each other. And for face milling, the tool and also the workpiece is perpendicular to each other. So meaning that it's rotate perpendicular. Okay, so this one, the tool and also the workpiece. Okay, so the position is parallel. Okay, so this one is and workpiece is perpendicular. So as I've mentioned previously, for peripheral milling, cutter axis is parallel to the surface being machined, and also the cutting edges on outside periphery of the cutter. So for face milling, cutter axis perpendicular to the surface being milled, and cutting edges on both the end and outside periphery of the cutter. Here are some type of peripheral, or we call it slab milling. Okay, so the first one is A is slab milling. Okay, so if they are machining the whole surface of the workpiece. Okay, and then we can the B one is slot milling. Slotting is a process where you want to create a slot on the workpiece. Let's say this one is like this, so that you want to create only this, like a hole inside. Okay, So if you can see from side, it might look like this. Okay. For the C is side milling, so this is the same, only that it create the workpiece. Okay, so let's say they just cut on this area only. So if you can see from the side, it's like this. Okay, and then we have also straddle milling, meaning that they cut two edges on the side. Okay, so if we cut, it become like this. Okay, the work material, the final one. And another one is form milling. Form milling is when you want to create a certain shape on the workpiece. So for this example, this one is like a hemisphere like shape, right? Like this one. Okay, so you can also change to another shape, but it depends on the tool for that the shape of the tool. So that if let's say you want to create a certain shape like moving like this one, so you will have to create the tool, you have to use the tool that can create the shape like this. Okay, for peripheral milling, there are two directions of the cutter. One is up milling and another one is down milling. So what is up milling? When up milling, it is like a ploughing, and the cutting is performed when the cutting the teeth is moving upward. Okay, as down milling, the cutter is moving downward. Okay, so when the cutter is moving downward, so that one is the down milling. So here are the type of face milling. A is the conventional face milling. So B is partial face milling, and C is end milling. Apart from that, we also have profile milling. So profile milling used usually to create a profile on the surface of the workpiece. And then we have pocket milling. Of course, if we want to create the pocket on the part, then we use the pocket milling. And we have also surface contouring, so meaning that if you want to create a contour on the workpiece, on the workpiece, you can create it using the surface contouring. Now let us see the cutting condition in milling. So for N, the equation is still the same, which is V over pi D. But the difference for the FR, they have additional for NT. NT is the number of the teeth. Let's say if you have more than one teeth used during the operation for the milling operation, so you have to include the number of the teeth in of the cutter inside this equation. Here is the cutting condition in peripheral milling. So in peripheral milling and also face milling, their approach distance that you have to take note. Okay, so this approach allowance. Okay, so this is A allowance is between when the cutting start touch and also to the center of the cutting tool. Okay, so to get this calculation, A equal to D minus D, the square root. Okay, so D is the diameter of the cutter, the small d is the thickness on how much is the removal of the material. Okay, so then you will get the value for A. So tm, the machining time is calculated using this equation. Okay, so and then the RMR using the WDFR. So FR is the feed rate, D is the depth, how much is the material is being removed, W is the width of the workpiece. Okay, so let's say this one is the workpiece, so the width of that width over here is the one that you have to use to calculate. And for the cutting condition in face milling, there are two types. Okay, So one is if the tool is located in the center of the workpiece, especially if the cutter is bigger than the workpiece that you want to machine. So the approach is calculated by using this equation. Okay, so next one is if the cutting tool is offset on the side of the workpiece, and then the machining is performed like this. Okay, so until it's finished. So this one, the approach is calculated by using this equation. Okay, so then the W is how much is the each parts, let's say the tool pass in one cutting movement. Okay, so then by using this after calculating the A value, then you can calculate the machining time by using this equation. Here is the problem for the milling, so you can try also. The method of solving the problem is still the same, only then the equation will be different. So give it a try. Okay, here are some link for milling operation. So hope it helped you to understand more about the milling operation. So that's the end of our class today. Thank you for listening. We're going to continue with metal cutting part 3 in the next class. Assalamualaikum.